Hello there. My name is Shannon Kuehn. Yes, it's pronounced Keen. And I am a senior cloud advocate on the enterprise platforms and tools team at Microsoft. I'm here today to talk about the next evolution of the Azure VMware Solution, or AVS for short. I might use that over the course of this presentation. For additional content as time unfolds, please feel free to connect with me on Twitter or LinkedIn as AVS continues to gain popularity with our customer base. Also, the aka.ms link that shows up there, it'll take you to our brand new documentation as well. At the present time, AVS version 2.0 is GA and deployable in East US, West Europe, and Australia East. Let's first start out by introducing the service. Azure VMware Solution delivers a comprehensive VMware environment as a service, which allows customers to run native workloads in Azure on VMware. Yes, you can now run your workloads on VMware. My mind blew up a little bit thinking about this probability over the course of anybody's digital transformation. It's definitely a new day in cloud computing at Microsoft. Azure VMware Solution breaks the paradigm in Azure. Customers can now migrate VMs directly from on-premises environments to Azure, landing on bare metal, purpose-built, hyper-converged dedicated nodes to run your VMware VMs in Azure, exactly as they run today in the hypervisor you both know and love, VMware. Customers can now seamlessly run, manage, and secure applications across VMware environments and Microsoft Azure with a common operating framework. Customers will be able to capitalize on their existing VMware investments, skills, and tools, including VMware vSphere, vSAN, and vCenter, while leveraging the scale, performance, and innovation of Azure. The Azure VMware Solution delivers VMware-based private clouds in Azure. The private clouds are built from clusters of dedicated bare metal hosts and are deployed and managed through the Azure portal. Clusters in private clouds are provisioned with VMware vSphere, vCenter, vSAN, and NSX software. AVS private cloud hardware and software deployments are fully integrated and automated in Azure. One thing to note, though, this is not our first time building bare metal and purpose-built solutions for Azure services. Along with AVS, we offer bare metal solutions for SAP, Cray, and NetApp. Using purpose-built bare metal infrastructure allows customers the ability to scale, operate, and not have to compete with a shared virtual environment. Digital transformation surrounds four distinct pillars: rehost, refactor, re-architect, and rebuild. Unfortunately, it's not straightforward to move from left to right. So our goal at Microsoft has been to provide as many options to customers as possible. This helps the ease of the digital transformation motions within each company. So AVS itself sits on dedicated hosts, which means the entire platform falls underneath the Azure dedicated side of our engineering house. Prior to this living in our world, customers had to land on IaaS outright. I think every customer wants to get to the far right as fast as possible, but sometimes that isn't easy. Maybe there's a commercial off-the-shelf application that doesn't seem to be getting new cloud-based development cycles, or maybe there's a company's proprietary application that will take some time to unravel because the developer who built it is no longer at the company. Technical debt is hard and ever present, even within the most robust and sophisticated IT environments. The beauty is you don't need to stall everything out in order to be agile and adopt cloud. AVS can help. There are quite a few triggers surrounding application migration and modernization, but it essentially comes down to two main motivations. First, it's breathing life into an existing application, and second, it's extending a legacy application by adding new functionality. Migration is the quickest way to unlock the benefits of flexible and scalable cloud infrastructure. So migration triggers include consolidation of data centers, hardware refresh cycles, or a general move away from on-premises systems. This is AVS's sweet spot, so to speak, as you can migrate your VM workloads directly to Azure in a quick fashion. Modernization tends to require more effort, but it unlocks even more advanced cloud capabilities such as increased business agility, global scale, and improved resiliency of applications and services. Modernization triggers include wanting to deliver your applications faster to users and customers, addressing security issues caused by legacy or outdated code, and enabling new business opportunities with innovative applications. In this diagram, you see the adjacency between private clouds and VNETs in Azure, Azure services, and on-premises environments. Network access from private clouds to Azure services or VNETs provide SLA-driven integration of Azure service endpoints. Private cloud access from on-premises environments uses Azure ExpressRoute Global Reach for a private and secure connection. Then once you've deployed AVS, you gain access to feature-rich offerings within the Azure portal. So let's step through the new and differentiated features because we did have a version 1.0 of our AVS offering, and some of these features have changed for the better. AVS version 2.0 is a first-party Azure service certified by VMware. Then there's a seamless Azure experience and native integration, which hopefully sheds light where everything you need to configure happens in the same Azure portal you would use for any other Azure service like a VM, a load balancer, or a web app. Companies can make use of the Azure Hybrid Benefit licensing for Windows Server and SQL Server, which reduces operational kind of CapEx costs. It's a great big plus on that side. Then if you're still running Windows Server 2008 or 2008 R2 or the SQL flavors of each version, you're eligible for the no-cost extended security updates in Azure by using AVS. Patching your environment becomes more cost-effective by migrating these VMs into Azure using AVS. If there are issues with the AVS environment and you need to escalate with support, you only have to call Microsoft. Microsoft will coordinate with VMware to resolve any issues you may face with your AVS environment. The AVS environment itself supports the latest VMware technology updates, so this helps you continue to move the mark forward and ensure the AVS environment supports the latest VMware technology updates. The Hybrid Cloud Exchange Enterprise Edition is available, which helps you migrate those VMs between on-premises and Azure using vMotion. I think if anybody's a VMware fan, and I know they are at the Runecast conferences, vMotion is an awesome technology. The AVS nodes are fast and highly performant using a hyper-converged infrastructure. There's also a concept of unified licensing and consumption using AVS and Azure. It showcases where you only have to go to one spot for all of your cost optimization and kind of breakdowns. There's also a simplified NSX interface using AVS 2.0 as well. So you have your familiar VMware interface, which means your operational best practices, your standard operating procedures, the way that you operate on a day-to-day basis, that can be met by using the same platform you do on premises. And then it's really as simple as selecting the service from the Azure portal, filling in the required fields, and deploying. That's a definite change in the positive direction for version 2.0. So AVS runs on Azure for modern, well-managed infrastructure, including high availability, DR, and backup. Plus, there's that rich third-party ecosystem in the marketplace as well that can be plugged in to help augment what's already being done in Azure outright or help bridge any sort of gap within your company. Think of AVS as another tool in your tool belt. If the timing is right and you're ready to make the hop, you sort of unlock an even greater potential once you lean on Azure to run those advanced workloads on bare metal servers, not surfaces, servers. I often think of this like achievement unlocked. As of right now, these are the different software and hardware specifications. These specifications will evolve over time. Billing uses an hourly pay-as-you-go model, and you can also consider using reserved instances, either the 1 year or the 3 year. The service requires a minimum of 3 AV36 nodes, and you can add additional single nodes as required. These are the common use cases or scenarios we tend to see. So first and foremost, it's data center expansion, reduction, or retirement. So you gain additional capacity when you reach the limits of your existing data center thresholds. It's also easy for you to add needed capacity in the cloud and eliminate any headaches of managing hardware refreshes. Customers can reduce the risk and cost of cloud migrations by using AVS compared to the sometimes time-consuming conversions or re-architecture going to IaaS outright. Plus, you're using familiar VMware tools and skills to accelerate cloud migrations, which helps. In the cloud, customers can make full use of Azure services to modernize applications at a pace that's right for your company. From there, we've got disaster recovery and business continuity. Customers can think about leaning on AVS to establish remote access to data and apps in Azure. With high bandwidth connections that use ExpressRoute, you can recover quickly from incidents. Low latency networks provide fast response times that users tend to come to expect related to their business applications. With AVS, it's easy to replicate VMs, all policies, and all networking using familiar VMware tools. The ease of recovery and replication greatly reduces the effort and risk of creating and managing DR implementations. From there, speed and simplification of migration. So you don't need to convert these VMs to IaaS or PaaS to gain any access into the cloud infrastructure of Azure. You can quickly migrate VMs with vMotion using HCX Enterprise. This makes the process so much faster than trying to analyze at what point it makes sense to move these workloads. Then you also have application modernization. So even though AVS is a lift and shift model, you can use things like Azure Active Directory, any of the advanced analytics, or even AI to start moving toward application modernization surrounding your VMware stack. So I want to take some time and talk through the deployment steps involved with building the solution in Azure next. So these are the high-level steps you take when you deploy a software-defined data center in Azure. You first deploy the AVS private cloud. From there, you'll create a virtualized network or a VNET if you're familiar with the Azure terminology. Afterward, you'll create an Azure Bastion host. You can also create a jump host. A lot of our customers are leaning on Azure Bastion because it's a secure way of accessing your environment over RDP. The Azure Bastion host allows access to the AVS environment from on-premises. You'll then create a gateway subnet in the VNet. You'll deploy a VNet gateway. You'll provide an auth key to connect the on-premises environment into Azure using ExpressRoute. And then finally, you'll connect your ExpressRoute to the VNet gateway. Seems pretty straightforward. Of course, I'm oversimplifying it a little bit. Then when you connect the VMware environment on premises and the AVS environment in Azure, you'll connect to the Azure Bastion host, and then you'll connect to the vCenter inside the Azure Bastion host. From there, you'll connect to NSXT. Then you'll enable global reach for on-premises access. And finally, you'll configure the on-premises environment with VMware Identity Manager. Now, these are the very quick and high-level ways of thinking through a full-blown deployment. It makes sense with most of the deployment processes in Azure. There's configuration that has to happen on premises and configuration that has to happen in Azure. You link it by way of networking. Let's talk a little bit about the management pieces of AVS, and we'll cover that topic at a high level. So the beauty of running VMware in Azure is you and your team will already be extremely familiar with all of the VMware tools and technology. After all, it's VMware on Azure. Using AVS allows you to create operational consistency for admins, since you'll use the vSphere client to access your cluster plus all VMs and then NSXT Manager for networking. Access to vSphere, HCX, and NSXT are enabled during the private cloud deployment process in Azure. Credentials are registered in Azure to the private cloud, the private cluster hosts. It's a little early my time. There's an ability to easily scale the infrastructure to match business needs through the Azure portal. Another thing to note is if you can do it in the portal, there's a REST API equivalent, so you could even think about automating some of this scale when you need it. You can add new nodes as required to increase compute and storage during peak times, which provides you a lot of flexibility. You can also delete nodes when demands are lower. The math is called out in the slide here. You need a minimum of 3 nodes per cluster. There's a maximum of 16 nodes in a vSphere cluster. And then there's a maximum of 64 nodes in an Azure Private Cloud instance. Often we show where the division of responsibility lies between the customer and Microsoft associated to shared responsibility as it relates to Azure. The model itself is related to Azure all up and looks similar. However, this chart focuses on the lines of responsibility for AVS itself. As you can see, Microsoft abstracts a lot of the ongoing maintenance, security, management, etc., leaving your company in charge of things that matter most: guest OS provisioning, applications, virtual machines. Plus, you can think about what it means to bring that lifecycle process into Azure with configuration management techniques as well. So certain types of headaches might go away by placing your platform in Azure and running your VMware vSphere environment in the cloud. I don't know if you're like me, but as time evolves, there are less headaches I could stand to deal with. And this is why I started believing in the cloud outright. So I think hopefully at this point, you're getting a little bit of an idea here on the ways in which Microsoft abstracts AVS to help you out on your day-to-day basis. Host maintenance and lifecycle management are done without impact on the capacity or performance of the private cloud cluster. So examples of the automated host maintenance include kind of firmware upgrades, hardware maintenance or replacement. Microsoft is responsible for the lifecycle management of the NSXT appliances, such as the NSXT Manager and NSXT Edges. Microsoft is also responsible for bootstrapping network configs, such as creating the Tier 0 gateway and enabling north-south routing. As an administrator to your AVS private cloud, you're only responsible for the NSXT SDN configuration, like network segments, distributed firewall rules, tier 1 gateways, and load balancers. One of the key benefits, though, here is that the platform is maintained for you. So platform maintenance includes automated upgrades, and everything is validated related to the vSphere bundle that you actually see deployed in your environment. The upgrades are done regularly, ensuring that you always have the latest validated versions of the software. The AVS private cloud platform includes specific versions of VMware vSphere, ESXi, vSAN, and NSXT software. The private cloud software bundle is validated for use in the new private cloud installations and then for upgrades of existing private clouds. The lifecycle management upgrade process doesn't require downtime for your private clouds. The upgrade process ensures you are automatically using the latest version of the validated AVS private cloud software. So upgrades are applied on a regular cadence, so your private clouds are never really more than one version behind the latest release of the validated software bundle. You'll be notified on planned upgrades to your private cloud. You can defer the upgrade of your private cloud if it conflicts with something going on within your environment. However, the recommendation is to only be one version behind the current release. Critical patches and updates are applied when they're validated, and then you'll be notified in advance of required critical upgrades. Let's talk a little bit about the network architecture next. So network interconnectivity between your VMware private cloud in Azure and on-premises vSphere environments, this enables you to access your private cloud over an ExpressRoute connection or some sort of hybrid connectivity. There are two types of AVS private cloud interconnectivity. There's the basic interconnectivity, which enables you to manage and use your private cloud with only a single virtual network in Azure, and then the full on-premises to private cloud interconnectivity, which extends the virtual network connectivity to also include interconnectivity between the on-premises environments and AVS private clouds. So at a high level, this is the basic interconnectivity. The implementation is best suited for AVS evaluations or implementations that don't require access from the on-premises environments. Think of this as maybe kind of the starter version of interconnectivity and network access for your AVS private cloud. There's logical express route based networking between a virtual network in Azure and a private cloud, as you can see within this diagram here. The interconnectivity fulfills three of the primary use cases: the inbound access to vCenter and NSXT Manager that is accessible from VMs in your Azure subscription and not from your on-premises systems. Outbound access to the VMs themselves to Azure services also account for the basic interconnectivity, and inbound access and consumption of workloads running in a private cloud. Those are the use cases the basic interconnectivity supplies. So the AVS private clouds require a minimum of a /22 CIDR network address block for subnets. The network topology that you select really should complement what your on-premises network is doing. So in order to connect to an on-premises environment and virtual network, there must be a non-overlapping network address block. Ever so slight caveat, we'll discuss that later, but that's the recommended go-forward pattern. Then to establish full interconnectivity to a private cloud from on-premises, you need to enable ExpressRoute global reach between a private cloud ExpressRoute in Azure and the on-premises ExpressRoute going into Azure from your on-premises environment. So an on-premises to Azure ExpressRoute circuit is required to connect the full interconnectivity range. So this ExpressRoute circuit will sit in your subscription and really isn't part of the AVS private cloud deployment. So the on-premises ExpressRoute circuit is really beyond the scope of this conversation, but know that if you require the on-premises connectivity to your private cloud, especially if you're migrating VMs from on-premises to Azure, you'll want to make sure you've got an existing ExpressRoute circuit and you've configured global reach. So once you've linked global reach with your ExpressRoute circuits, those two circuits route network traffic between your on-premises environment and your private cloud. So to enable the full connectivity of this entire solution, an authorization key and a private peering ID for global reach can be accessed or requested through the Azure portal. You use the key and the ID to establish the global reach connection between the express route circuit in your subscription, and then also the express route circuit that gets deployed between ABS and your environment. So this implementation enables the following use cases: the hot and cold migration, or the vCenter vMotion, right? And then on-premises to ABS cloud management access. AVS supports a VPN connectivity pattern for POC. Another caveat here is if you don't need to migrate your VMs from on-premises into Azure, you could think about leaning on a site-to-site VPN. Sometimes getting an express route circuit takes some time. So maybe it's one of those things where you place a site-to-site VPN connection in to help related to that migration pattern. So you do have flexibility of deploying it this way. Again, the recommendation is to only lean on this for POC, as VMware at the present time is not guaranteeing SLA using vMotion over a site-to-site VPN. So let's take some time to talk about what a migration pattern looks like next. So similar to other third-party tools, companies need to assess their VMware environment using Sizer. You can use Azure Migrate. There's a number of these tools that sit out there. So customers will have a better understanding of the workloads they intend to migrate after going through an assessment period. The migration approach can be done as a live migration, a bulk migration, or a cold migration using HCX. Plotting everything out in this manner means customers have more time to identify all steps for workloads to reach full production. Of course, customers will want to go through a number of tests and validation. We encourage that, right? I think most customers like that fact. So, you need to be able to feel confident that the solution is viable for your company. You'll create a private cloud, you'll move a few VMs using the preferred migration type, and hopefully encounter no issues because you'll have worked with Microsoft or a Microsoft partner to help. From there, the POC will be deemed as over, and then it's time to transition to production, where the at-scale migration and adoption is important, right? So we offer up Microsoft Fast Track. We also have a number of Microsoft partners if the skill set doesn't exist in-house. So you're never alone throughout this whole entire process. Microsoft is here to help. Azure Migrate now supports assessments for Azure VMware Solution, providing even more options for customers to plan their migration path into Azure. So previously, Azure Migrate tooling provided support for Windows and Linux servers, living in an IaaS world. Newer features contain things like being able to migrate databases and web apps, as well as virtual desktop scenarios. Customers are able to use the same migration hub now and assess machines for migrating to AVS. Using the Azure Migrate Server Assessment tool, customers can analyze readiness, Azure suitability, cost planning, performance-based right sizing, application dependencies for migrating to AVS as well, right? So it's a nice, neat, nifty tool to think about if you're not sure how to assess your environment. The AVS assessment feature is currently in public preview, and the solution supports up to 35,000 VMware servers in one Azure Migrate project. Hybrid Cloud Exchange, or HCX, becomes the tool to lean on here related to migration. So as of right now, HCX Advanced comes with AVS 2.0 as soon as the cluster is deployed. In order to move VMs from on-premises into Azure, you will need HCX Enterprise, which is essentially an add-on you can obtain through Microsoft support. HCX Enterprise carries additional charges that will be billed monthly. So HCX can support large-scale bulk migrations of VMs, which is a really compelling story if your environment contains a lot of VMs and you need to get everything out of your existing data center in a fast fashion. HCX also supports any vSphere to vSphere migration pattern, which sort of adds extra functionality to the table. It's not just a migration pattern into Azure. It's really the Swiss Army knife of the VMware environment related to migrations. So note here, the vSphere version needs to be 5.0 and newer to make use of that migration pattern. That's one big thing to note here. Sometimes I work with customers who are running older versions. So get to 5.0 and you'll be able to then make use of AVS in Azure. HCX can be part of a site pairing and DR as well, which means high availability will follow your app around, regardless of any disasters, user errors, or equipment failure. HCX offers parallel VM migration threads as well, which helps speed that process up. And then, regardless of any, situation, you'll feel less single-threaded related to migration. HCX does not require an IP address change. I know I had talked about how when you're plotting out your networking, you want to make sure that your networks in Azure don't overlap with on-premises. Well, HCX allows for that to happen in the event you need it, because there still are workloads that are out there that require the same IP address. There's no NAT involved either, which is great. So that really starts to become an easy conversation with customers that don't need their IP addresses to ever change. HCX also provides a secure proxy for vMotion and replication traffic to hopefully kind of appease security-minded customers as well. This slide here really covers the logical stretched layer 2 network. So, if this is a want on the part of your company, you'll just need to factor this into the overall deployment related to moving VMs from on-premises into Azure. So in order to set this up, global reach should be configured between on-premises and Azure VMware Solution, the SDDC itself, via the express route circuits, right? So all required ports should be open between on-premises and the Azure VMware Solution SDDC. You'll need one IP address for the HCX manager on-premises and a minimum of 2 IP addresses for the interconnect and network extension appliance. So factor that in, right? And then the on-premises HCX interconnect and network extension appliances should be able to reach the vCenter environment and ESXi infrastructure in Azure. So to deploy the WAN interconnect appliance, in addition to the /22 CIDR network address block used for the SDDC deployment in Azure, HCX requires an additional /29 block. So it's a lot of pre-planning on the networking front, just related to factoring in what your address space should be. And then you could always carve those up, but that's the general recommended pattern related to your network planning. So let's talk a little bit about storage. This way you'll kind of understand what gets deployed. So AVS private clouds provide native cluster-wide storage using VMware vSAN. The vSAN storage is a fully configured all-flash vSAN storage device, which is local to the cluster. All local storage from each host is used in a vSAN data store, and data at rest encryption is available and enabled by default. You can use Azure storage resources to extend capabilities of your private clouds as well. So deduplication and compression are enabled on the vSAN data store by default. In addition, 2 disk groups are created on each node of the vSphere cluster. Each disk group contains 1 cache disk and 3 capacity disks. You'll create at least 1 vSAN cluster in each private cloud. You can add additional clusters to a private cloud using the Azure portal or through the API. All clusters have a default size of 3 hosts and can be scaled up from 3 to 16, as I covered earlier in the session. The type of hosts used in a cluster must be the same type. You create, delete, and scale clusters through the portal or the API. You still use vSphere and NSXT Manager to manage most other aspects of cluster configuration and operation. All local storage of each host in a cluster is under control of the vSAN. So vSAN data stores use data at rest encryption by default. The encryption solution is a KMS-backed scenario or KMS-backed solution that supports vCenter operations for key management. Keys are encrypted, wrapped by an HSM key vault master key as well. So when a host is removed from the cluster for any reason, data on the SSDs is invalidated immediately. Native cluster storage capacity is scaled by adding hosts to a cluster, and it's a matter of adding that scale to the portal or via the API. You can use Azure Storage Services on workloads running in your private cloud, as I had covered. So the Azure Storage Services include things like storage accounts, table storage, and blob storage. The connection of workloads to Azure Storage Services doesn't traverse the internet as well. This connectivity provides additional security and enables you to use SL-based Azure Storage Services in your private cloud workloads. In terms of the vSAN storage policy, the policy itself is created on the vSphere cluster and applied to the vSAN data store. This policy determines how the VM storage objects are provisioned and allocated within the data store to guarantee the required level of service. This policy also defines the failures to tolerate and the failure tolerance method. So to maintain SLA, 25% capacity must be maintained on the vSAN data store at any given time. We can talk a little bit about security and compliance next. So using Azure means you're starting with a secure foundation. You're able to take advantage of the multi-layered security provided by Microsoft across physical data centers, infrastructure, and operations in Azure. By building solutions in Azure, you gain from the state-of-the-art technology and security delivered in Azure data centers globally. So you get to rely on a cloud that is built with customized hardware, has security controls integrated at the hardware and firmware components, and you get the added-on protections against things like DDoS attacks. Additionally, you may not know this, you can benefit from a team of more than 3,500 global cybersecurity experts that work together to help safeguard your business assets in Azure. So Microsoft has quite a number of CISSPs. It even shocked me because I don't think of CISSPs in Microsoft. It's something we don't take lightly. Security is a big part of what we present and what we build out related to our platforms. So everything from certified data centers, hardware, and cloud environments to network edge security and DDoS protection. So we also offer up a strong IAM solution with Azure Active Directory and security services you can bolt onto that licensing model for things like conditional access, enforcing MFA, et cetera. Couple the inherited security from Azure with the VMware inherited security of data encryption at rest, host security, encrypted vMotion and kernel traffic. You can also think about granular RBAC and the private cloud security. This really becomes a very secure platform offering for customers. So when we think about the Microsoft Azure Physical Data Center security, so all locations that we have infrastructure deployed in, they're staffed 24/7. No unauthorized personnel is allowed in the environment. So if you ever go and tour a data center, it's possible. It's not an easy process. You have to make an appointment. You have to work with your Microsoft account team. It's not like I could go tomorrow down to the data center in close proximity to where I live and get in and take a look at things. The metal detectors and security screening are there. So you've got the equivalent of you have to make sure everything's scanned, that it's, doors don't open until you actually make your way into kind of that little trap, right? And then the door behind you shuts and the next door opens. So it's a pretty hard environment to get into. From there, there's the biometric scan upon entry. So there's a sign in and visual as well. There are hundreds really, not just 100, hundreds of security cameras, including security cameras on each rack. So if you were to tour a newer data center where everything lives in a pod outside, you're actually not even allowed to get off the bus. If you are able to go into a data center that actually has racks of servers, just know that there's a security camera on you at every step of the way throughout the entire process. Video archivals are available upon request. So if you feel like, you wanted to take a look at what somebody was doing while they were in there, you can request that, right? So usually it's big groups of folks that tend to go. It's not just, one or two people. It's a team of folks that go with Microsoft account folks to kind of think about how all the security works. And then a location of every person is tracked within the DC. So I toured one a couple of years ago, and I had a badge that was given to me, and it turned red over the course of the 3 hours we were there. And none of us were allowed to deviate. We always had somebody with us. We always had our location tracked throughout the entire time we were in the data center. Kind of crazy if you think about it. And then, the private cloud you create with AVS has some great security enhancements as well. So there's data encryption at rest on vSAN clusters using external keys. Customers can supply keys and they can, use the external KMS system. So BYO license key is a cool scenario for customers that are very security minded. So you're not really giving up or adhering to a different set of rules by using AVS. You get to take the same level of security and plug it into Azure. vSAN data services kind of remain unaffected from the encryption as well. So these are the compliance certifications AVS has at the moment. So compliance certifications are definitely a big part of our enterprise cloud, and we push for services that are enterprise ready to hold these certifications out the gate. So this space will continue to evolve as more customers with compliance requirements embrace AVS for their VMware deployments. And I've got a demo here, and I'll start by saying it's a pre-recorded demo. This is not me actually doing the configurations, but it's hard to demo the service because it sits on bare metal servers. So the environments we've got to demo at Microsoft, usually all of us have read-only access. So we'll have to go through the notion of this video here, and then I can turn to any questions that have shown up in the chat. So in this demo, I'll walk you through what it's like being an admin for Contoso Health Services. So Contoso Health Services is a longtime VMware shop that provides billing and other patient services to doctors around the globe. So as a company, they're looking to Azure to help expand and modernize. So I'll show you how easy it is to get started by creating your first private cloud, how you can use the existing VMware tools you know and love to manage your private clouds in Azure. Might help if I actually play the video, right? And then how you can take advantage of key capabilities in Azure, like our global footprint, the AZ CLI with very little friction. So this whole process doesn't take too long to set up, but I wanted to be able to start in on kind of highlighting that it's as simple as going into the Azure portal and starting to select the services. So you'll see here, you're selecting the Azure VMware Solution. You're clicking on Create. It needs a subscription. It needs a resource group, a location, the resource name. There's the SKU. Then it requires the vCenter admin password. You confirm it. Then you've got the NSXT manager password. You confirm that password. Then you'll provide the address block, link it to a virtual network, review and create, and then hit create. So a little time has passed, and now there's, you're seeing this show up here on the dashboard. So you can see the AVS solution that shows up. So by clicking on the link, you get a chance to go kind of tour the private cloud and manage its capabilities. So you can manage connectivity, which is kind of cool. You can manage take a look at the metrics, the identity, the clusters. So the connectivity itself, you'll see ways to configure the express route. You'll be able to take a look at the public IP address that gets assigned, the HCX manager IP. This is where you configure the express route global reach. And then from there, you've got add-ons. So if you are a site recovery manager customer, you're able to bring your own license key and make use of this within AVS, which is kind of nice. And then if you want to get into your environment itself, it's as simple as logging into the Bastion and connecting into the, so you connect into the Bastion host with creds that you normally use. And then once you're in, you'll see the vCenter environment that I think everybody feels comfortable looking at, right? Just looks like it does as on Prem. Let's take a look at the vSAN data store. And this is all the networking, the different segments. This is the NSX manager that highlights the different segments. This is where HCX has been configured and it's deployable between two different regions. So let's take a look at the content libraries. This is a cool way to expand what you normally do. So take a look at the fact that it's sitting in an Azure Blob Storage account. So you could store anything living in a content library in an Azure Blob Storage account, which is kind of a cool reality of bolting on different services. Then when you go into the storage account itself, you'll go into the containers and you'll see exactly what shows up inside of what you see in the vCenter environment. Kind of a cool way of expanding what you normally do on a day-to-day basis. So let's say you needed to expand the cluster. Say you needed to move it from 3 to 4. So you could actually adjust that here by way of clicking on the ellipses to the right. Or you could think about leaning on some of the automated tooling that has been built out with the AZ CLI. So you see that you've got the VMware commands. So you just plug this in, and this will help you. This is some of the ways to think through automating scale up motions. And you'll see that the cluster has been updated, and you see a provisioning state as succeeded. So when you flip over to the portal, you'll see the host number change from 3 to 4. which is a pretty cool reality. So as it relates to AVS, it's pretty straightforward to set up. It's pretty straightforward to integrate. It's pretty straightforward to think through what your day-to-day would look like on a regular basis. You can even think about taking on tooling that helps in that scenario as well to provide some more automation. So that's the end of what I've got here. And I will take a look at the questions. Okay, so let's see. Aside from the fact that it's running, good question. So, Kev, I think some of the ways the question is this. So aside from the fact that it's running in Azure, what are some of the key differentiators between AVS, VMC, OCVS, et cetera? So I think the idea that once you get into Azure, you unlock a lot of the Azure native services that sometimes are hard to get plugged into hybrid environments or hard to embrace when you don't have environments sitting in close proximity to Azure. So you can make use of Azure Active Directory, you can make use of Azure Security Center, Azure Monitor, Azure Sentinel. You can think about starting to build out any analytics platforms that you would like to. Maybe you don't have the capacity to build a VM on premises to handle a data warehouse. You could think about moving some of those workloads into Azure. So, kind of getting to that point, you reach a kind of achievement unlocked sort of state. And then KMS uses an HSM, not just software for key management. Yeah, so it can. So the one thing here is it's not like an actual service that you buy specifically. Like, so if you have your own HSM, you can tie it to Azure Key Vault, and Azure Key Vault can store those HSM keys in Key Vault so that, what you're referencing is a Key Vault secret, not the actual key, if that makes sense. So I wanted to just come back on and say thanks for the opportunity. Jason, I think you were on here. So thanks for the shout out to submit. Appreciate it. And I appreciate the opportunity to talk to all of you. So feel free to connect with me if you've got any additional questions or you want to talk about any of these components a little bit deeper. If I don't know the answer, I've got somebody that knows the answer. I work for the company that built the service with VMware, so I can hopefully get you the answers you're looking for and help out. But thanks again. And I think we'll just end it right here.